There we go. Okay. We were talking about balancing chemical equations. We did one example, and here's a couple more examples. So the problem states write a balanced equation for the combustion of gaseous ethane. They give us the formula because we haven't discussed what the formula would be yet. A minority compound of natural gas, in which it combines. So the combustion of ethane in which it combines with gaseous oxygen to form gaseous carbon dioxide and gaseous water. So we're interpreting words and turning them into a chemical formula. So when we see the word combines with, that's going to be a plus sign. Oh, that's not what I wanted to do. There we go. Combines with, that's going to be plus. To form, that's where the arrow is, and is plus. So the first thing we have to do is write the chemical formulas for the compounds. So we have ethane. That one was given to us. C2H6. And what is the physical state? It's a gas. They tell us that in the problem. Combines with gaseous oxygen. So oxygen in the gas state, oxygen is an element. So then we have to ask ourselves, is it one of the 7 diatomic elements? Yes, it is. So we have to write its formula as O2.
What was that saying again?
What was the saying? Horses need oats for clear brown eyes. So that's one way to remember. It's hydrogen, oxygen, hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. And they're kind of clustered in the periodic table too. But writing chemical equations is one place where we need to remember those. And so then we have to form, so there's our arrow, gaseous carbon dioxide. What's the formula for carbon dioxide? CO2. It's a molecular compound. There's no prefix on carbon, so we assume there's 1. And dioxide means 2 oxygens. And we're told that it's a gas. Plus gaseous water. What's the formula for water? H2O. And that's a gas. Any questions yet? Now we need to balance it. So I'm going to use my tally method just to illustrate it for you. So in the tally method, we're going to draw a vertical line at the arrow. We're trying to get equal numbers of atoms of each element on each side. And then I'm just going to go through the reactants and list the elements in the order in which I come to them, because that seems the most straightforward to me. We've got carbon, we've got hydrogen, and we've got oxygen. So under the formula for C2H6, I'm going to identify how many carbons, hydrogens, and oxygens are in the formula. So there's 2 carbons, and there's 6 hydrogens, and there's 0 oxygens. And I'm just going to do that for each compound or each element. So over here, O2, well, there's no carbon, there's no hydrogen, but there's 2 atoms of oxygen, because the formula is O2. CO2, we've got 1 carbon, 0 hydrogens, and 1 oxygen. Thank you. 2 oxygens. Yeah. It's Tuesday. There's just no excuse. It was Super Bowl weekend. Yes. Broncos. 0 carbons, 2 hydrogens, 1 oxygen. Did I do that one okay? If you have lined paper, that's kind of nice, because as you can see, mine are dragging all over the place. I'm going to look at the top line. Carbon, on the left of the line, I have a total of 2 carbon atoms. On the right side, I only have 1. I can't reduce the number in C2H6. I can't change any of the subscripts in the formulas, but I could say, well, I must have 2 of these molecules then. And I'll put a coefficient of 2 there. That changes the numbers underneath. Adjust them right away. So that's going to be 2, and now there's going to be 4 oxygens. Each molecule of CO2 has 2 oxygen atoms. If I have 2 molecules, then I have 4 oxygen atoms. So now the carbons are balanced. 2 on this side, 2 on that side. Hydrogen. I've got 6 on the left side, and I only have 2 on the right side. How can I fix that? I'll put a 3 in front of water. If I have 3 water molecules, then I'll have 6 hydrogen atoms, and then I'll also have 3 oxygen atoms. Fixing that did not mess up the first line, so I don't need to go back and revisit what's going on with carbon. And now I'm going to look at the bottom. Oxygens. Here I've got 0 and 2, and I've got 4 and 3. So I have a total of 7 on the right side and 2 on the left side. This is what I call the odd-even problem. You can use fractions here and then clear the fraction later, but most students don't really like fractions that much and would rather avoid using them. How can you make an odd number into an even number? If you multiply by 2, right? So if we multiply everything by 2, we could probably change this 7 into a 14. So that's what I'm going to do. I've got an odd-even problem, and so I'm going to double things. So I'm going to go up here, and I'm going to make this 2 ethanes. Well, that makes 4 carbons and 12 hydrogens. I know that looks like a Z. Let's fix it. That's a 2. 2. I'm not going to do anything to this oxygen yet because that's the one I'm trying to fix. And then I'm going to go over here and I'm going to double that. It was 2. I'm going to make it a 4. That makes this 4, and that makes this 8. And then my 3 water molecules are going to be 6. So now I have 12 hydrogens and 6 oxygens. Everybody okay with that? So I didn't mess up the balancing I'd done in carbon. Now I've got 4 and 4, and hydrogen's still okay. I've got 12 and 12. And now oxygen. Oxygen isn't fixed yet, but on the right side now, I have 14 oxygen atoms, and on the left side, I have 2. Can I make 2 into 14 by multiplying? Yeah. I just need to multiply by 7. I'll put a 7 in there, and that makes the 2 become a 14, and now everything's balanced. Any questions? Yes?
There's like a problem like that on the home where the coefficient was like 25 or 30 or something.
Mm-hmm.
Can we still do like that and just multiply up to get that number?
Yeah, so there was a homework problem where coefficient was like 25, and you're getting this odd-even problem. Yeah, just double everything. Some chemical equations have very large coefficients. Most of them do not, but 25, 50, that's not unheard of. And so don't be too afraid of that. Once you get all your coefficients, it's a good idea to look back over it and see if they have a common factor and you could reduce them. Because occasionally you overlook something when you're balancing and you end up with everything multiplied by 5 or something silly like that. So if you come down to an odd-even problem, because here the oxygens are coming in pairs, and you can't just have one more oxygen atom, they come in 2s. And I needed an odd number on the other side. That's what I call the odd-even problem. Double everything, and usually that'll fix it. The other thing that sometimes happens is you start balancing, and you feel like you're ending up going in circles. It's like, okay, I'm fixing the oxygen, but then that's messing up the carbon, and then I have to fix that, and it messes up the hydrogen, and I'm going around and around. Just stop. Don't erase, just move down the paper, start over, starting with a different element. I have found that a lot of times that if I plug my laptop in, then I don't get this annoying message. and yet I still persist in not plugging it in. I found that a lot of times if you just start at the beginning of the, with the first element in the balanced chemical equation, that it often turns out okay. I have no idea what happened here. It seems to be okay. So any questions about that last one? There it is again. Everybody okay with that? Let's do another one. The title on this example is a little different. Balancing chemical equations containing ionic compounds with polyatomic ions. What we often see, not always, but often, is that polyatomic ions remain intact in a chemical equation. And so you can still balance by individual elements, but you can also consider a polyatomic ion as a unit. And so I'm going to do this problem in that way. So here's the statement. Write a balanced equation for the reaction between aqueous lead-2 nitrate and aqueous potassium chloride to form solid lead-2 chloride and aqueous potassium nitrate. So the first thing we have to do is write formulas. These are ionic compounds. So we need to look at the ion formulas with their charges before we can write the compound formulas. So this first one is lead-2 nitrate. What's the formula for lead-2 ion? Pb 2+. It has a Roman numeral because we can't figure out what the charge is from the periodic table. The Roman numeral tells us what the charge is. And then nitrate. What's the formula for nitrate? NO3, and what's the charge? -1. Why? Just because, right? Why is my name Jody? Because my parents decided to call me that. There is nothing better than that. Why is this nitrate? Because it's what we decided to call it. So how do we put these two together to form a compound? We can do crisscross thing, where we take this charge 2 and make it the subscript on the nitrate. Or we can think about it and say, well, I'll need 2 of these -1 ions to balance the charge on the +2. However you think about it, we should end up with the same formula, which is Pb NO3 2. And we're told that it's aqueous, so we put AQ in parentheses afterwards. Okay, so that's a little practice in writing formulas. Aqueous potassium chloride. What's the formula for potassium ion? Well, the potassium ion is K, but what's the charge? +1. And chloride comes from chlorine, and what charge does that have? -1. So +1 -1, all we have to do is push these two together. KCl, and that's aqueous. The first product mentioned is lead-2 chloride. Well, that's this ion and this ion together. They're the same ions that were in the reactants. What's happened is they're just switching partners. So we've already written the formulas. Now we're going to look at Pb2+ with Cl-. We're going to need 2 chlorides to balance the charge on the lead. PbCl2, and we're told that that's a solid. And then the other one is these two guys, nitrate and potassium. But we always write potassium first. You have a question?
I was corrected. I don't know which was right, but is for chloride is Cl-, not Cl2-, because
Chloride is always Cl-, because it's in group 7A, and so it forms a -1 ion. So K+ and NO3-, they each have a charge of 1, and so we don't need any subscripts or anything, and we're told that that one's aqueous. Any questions about how I got the formulas? Because I know we're still learning that, right? It's not going to go away. Okay, so here we have nitrate, NO3, and over here we have nitrate, NO3. It didn't come apart. Sometimes it will, but mostly not. And so I'm going to look at this as a unit. So let's do this tally method again. So I'm going to draw a line here. And I've got lead, and I've got nitrate, and I've got potassium, and I've got chlorine.
You want to look at the nitrogen oxygens too separately,
You can look at the nitrogens and oxygens separately if you want to.
but
You always can. But I think it's faster if you recognize the polyatomic ions. So it's a matter of personal preference. But I want to show you the group method because I already showed you the element method.
gotcha.
So now I'm just going to take inventory, and I'm looking at this compound, lead nitrate. This has one lead atom and two nitrate ions. So I've got one lead, I've got two nitrates. No potassium, no chlorine. Over here for KCl, no lead, no nitrate, one potassium, one chlorine. PbCl2, one lead, no nitrates, no potassium, two chlorines. And here at the end, potassium and nitrate. So no lead, one nitrate, one potassium, no chlorine. Everybody okay with that? Then I'm just going to go down the list here, and I'm going to look at lead, and I've got one on this side and one on that side. That's balanced. That's cool. I've got two nitrates on this side. I only have one on the right side. So I need to put a coefficient in front of the whole formula, and that multiplies the nitrates and the potassiums. So now nitrate's balanced. Now I'm going to look at potassium. I've got one potassium on the left and two on the right. So I need to put a 2 in front of KCl, and that changes its numbers below. So I've got two potassiums and two chlorines. So potassium is balanced now, and ta-da, chlorine is also balanced. Any questions? Some? Yes? The name for the compound? The method? I call it a tally method because I'm basically just tallying up the different parts. And I kind of came up with that almost out of desperation, trying to help students who just didn't understand what I was doing with these numbers, right? If you are struggling with the idea, the concepts of balancing chemical equations, please talk to me. Especially, we're going to have a little time during lab if you need some help. And we have some model kits. And sometimes all it takes is actually making the models and figuring out, oh, I can't take these pieces apart and make what I'm supposed to make yet. I don't have enough. I'm going to need another one of these. And sometimes when you actually see the pieces, then it makes sense. And once you see what's going on, this is not a hard concept. Until that happens, yeesh, it looks like weird magic. Some strange magical game. Yeah, that's no fun for most of the people. Any other questions?